Okay. So this case is about finding the distance from an external point to the line. But I'll have to explain you the case with the question. So have a look at question 20. Okay, so the situation is something like this. There is a line and there is an external point Q, coordinates are 1, 2, 3, and what we are interested in, we are interested in finding out the perpendicular distance from Q to the line. This is what we are interested in finding. So whenever the question says distance from a point to a line or distance from a point to a plane, so it implicitly means that it's the perpendicular distance. Because distance could be anything, so it means perpendicular distance. The question will not explicitly say the shortest distance or the perpendicular distance, it would just say distance. So it will mean perpendicular distance. Okay, so this is what we need to find. Now, the idea is this. The very first thing you need to do, that's your step 1. You need to identify the coordinates of this point right here. It's a special point, and let me label it as F. This point is called the foot of the perpendicular. It's called the foot of the perpendicular. It's a point on the line where you would say that if I were to draw a perpendicular from the external point to the line, it would touch the line at this point. So this point is called the foot of the perpendicular. Your first step is to state the general coordinates of F. So that would be through the parametric equation. So your step 1 is convert this to the parametric form, the line equation. I guess that would be x equal to 3 plus mu, y is equal to 4 minus 2 mu, and z equals minus 2 plus 2 mu.
How can we show that this point Q will always form a perpendicular line?
No, I'm not sure. I want to find this distance. I want to find a perpendicular distance.
So the point can be anywhere, but we can like.
And wherever it is, if you try to find the distance from an external point to a line, it has to be the perpendicular distance. Because distance to कुछ भी हो सकता है. Like, I mean, how far is the line from a point? So when we say how far is the line from a point, we are actually trying to say how far it is, what is the perpendicular distance from that point to the line. So that's what I'm trying to do. And therefore, that is why this point is so special on the line F, because it's positioned on the line as such that it forms a perpendicular with the external point. So that's why we're calling it the foot of the perpendicular. Okay, so this is the parametric form. Do you agree that the parametric form is also the general coordinates of any point on the line? We've discussed this before. What do you mean by x is equal to 3 plus mu? What is y is equal to 4 minus 2 mu? What are they trying? What is this equation trying to tell you? It's the general coordinates of x, y, and z anywhere on the line. So you keep different values of mu, you'll get different points on the line. How do you get that? Because these are the general coordinates of x, y, and z on this line. So can they be the coordinates for f? If x, y, and z can be any point on the line, x, y, and z can be any point on the line, then x, y, z, can I say that the coordinates of f generally are 3 plus mu, comma 4 minus 2 mu, comma minus 2 plus 2 mu. Are we okay with that? So if they are coordinates of any point on the line, so they can be the coordinates for the perpendicular as well. Are we okay to hear? Alright. So this was your step 1. You give the general coordinates for f. Step 2. Now, for step 2, there's one thing we all need to agree on, and that is that there is a direction vector that runs parallel to your line. Which is this one, 1 minus 2, 2. If the direction vector runs parallel to your line, then can I say that this perpendicular FQ is also perpendicular to the direction vector? if this FQ is perpendicular to your line, is it also perpendicular to the direction vector? We all agree on that? Okay. So your step 2 is this. You form a vector between the foot of the perpendicular and the external point. Now, either you can form an FQ vector or you can form a QF vector, that's your call. Which one you want to form? FQ or FQ? Okay, let's form the FQ vector. So that would be Q minus F, 1 minus 3 plus mu, that I guess that is minus 2 minus mu. 2 minus this would be minus 2 plus 2 mu, and 3 minus 2 plus 2 mu would be 5 minus 2 mu. This is your FQ vector in terms of E. Now we've all agreed on the fact that because FQ is perpendicular to the line, so the FQ vector is also perpendicular to the direction vector of the line. We've all agreed on that. So if that is the case, then can I say that FQ dot D has to be equal to 0? What's the characteristic of two vectors being perpendicular? The dot product is 0. So FQ, do you agree that FQ dot D would be 0?
Yes.
Okay. This FQ dot D equal to 0 will give you the specific value of mu. That specific value of mu for which your F will be placed on the line as such that it would be perpendicular to external point Q. See, mu can be any value. These are general coordinates of any point on the line. I want a point on the line as such, placed as such, like point F, that is perpendicular, forms a perpendicular with the external point. So for what value of mu will I have this F here? That's the idea. So wherever F would be, if it's forming a perpendicular, it has to be perpendicular to the direction vector as well. And their dot product has to be 0. Through this dot product, you will get that value of mu. So let's do that. Let's get the value of mu. Okay, the direction vector, by the way, is 1 minus 2, 2. 1 minus 2, 2. This you know is equal to 0. This is your step 3. So dot product minus 2 minus mu is multiplied by this would be plus 4 minus 4 mu, and 2 times 5 minus 2 would be 10 minus 4 mu. Check. You must be getting mu as 4 by 3. Check.
Yes, sir.
Mu is 4 by 3. Are we all good till here? Any questions? Step 4. You've got the specific value of mu where your F is perpendicular to the line forming a perpendicular to Q. Now there are two ways of getting the distance over here. This is the last step. Either you plug the mu back over here into the F coordinates, get the coordinates of F, and then use the coordinate geometry distance formula, if you remember, x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square whole root. You do that and get the distance between F and Q. And that is your perpendicular distance. This is one way of doing this. Yes. The other way is, which I generally prefer and I do it, is that I plug mu back here into the FQ vector. I get the FQ vector and then I just take the mod of FQ. What does the mod of a vector give you? It gives you the length of the vector. And in this case, the length of the vector FQ is also the perpendicular distance from the external point to the line. So plug the mu back into FQ, get the FQ vector and just take the mod of it. So yeah, you will plug it back here. So FQ vector is actually mu is 4 by 3, so this is minus 10 by 3. This is 2 by 3. And this is 6 by 3. Check. Minus 10 by 3, 2 by 3 and 7 by 3. And then once you have the FQ vector with you, just take the mod of the FQ vector and you should have your distance. And I think the mod of the FQ vector is coming out to be 17 to be exact. Is it root 17?
Yes.
Remember root 17 or did you do it?
Yeah, this is the early class. Is it root 17?
Yes.
Are we okay with the 4 steps? This is standard way of finding out the distance between the external point and the line. It's 4th step procedure. Anyone not okay with it? Please tell me. Also step 4. अच्छा mu आ गया आपका 4 by 3. Okay. So once you have mu with you, plug it back here. You have FQ internal. Plug it back here. You will get the actual FQ vector. The FQ vector is this right here. If I find the mod of FQ, what does the mod of vector give you? The mod of vector gives you the length of the vector. So the length of this vector right now over here is basically the distance from the external point to the line. So all I did was I plugged it back, got the FQ vector, and I took the mod of it. Should have your distance. Root 17 meters. Any questions? Are we good? Okay, this is one way. There's another way. I'll show you the other way as well. And then it's up to you, whichever method you want to use in the paper, because the paper won't be method specific. So, but you should know the other method as well. Let's take the same question. Okay, so this is the foot of the triangular, this is your external point Q. One new thing in this diagram would be the fixed point of the line, which you already know in the vector equation. What's the vector equation, by the way? Vector equation here. 3, 4 minus 2 plus lambda times mu times
1 minus 2.
1 minus 2? 1 minus 2. This is your vector equation. So I guess 3, 4 minus 2 is your fixed point on the line. So 3, 4 minus 2 is your fixed point on the line. Okay, so this procedure says, what you do is, step 1, you form a vector between this fixed point and the external point. Form a vector between the fixed point and the external point. Let's say vector AQ or QA, whichever one you want to form, that doesn't matter. I'm forming vector AQ. So let's form the vector AQ. Q minus A, minus 2, minus 2, minus 2, minus 2, minus 2, 5. This is your vector AQ. Are we okay with it? The next step involves a concept that we done in P1. At the end of the vectors chapter in P1, I get a concept called the projection of a vector. If you remember, I'll just recap it. Projection of a vector. Let me just recap it over here. So let's say there is a vector A, and there is another vector B. The projection of one vector on the other is basically, it's like a shadow that one vector casts on the other. So this length is called the projection of vector A on vector B. So it's like a shadow that A casts on B, and when you find the projection comes out to be the length, basically. Is the length from this point till here. And how do you find the projection? If you remember, it's A dot B hat. It's A dot unit vector B. If you're finding the projection of A on B, it's A dot unit vector B. If you're finding the projection of B on A, it's B dot unit vector of A. So this would actually give you this distance from here till here, this distance. Now I'm going to use this projection of a vector concept to actually get this distance out. I'm going to use the projection of the vector concept. So projection of vector AQ, the projection of vector AQ on the line to get this distance out AF. Now obviously I need another vector on the line. Do you have a vector on the line AF? Or maybe parallel to the vector line AF? The direction vector, yes. The direction vector runs parallel to your line. You can use that vector. But you have to take the unit vector of it. So if you remember how to convert a vector into a unit vector, so any vector can be converted to unit vector by taking the vector and dividing by its own magnitude. So we need to take the dot product of the vector and the other vector's unit vector. So in this case, step 2 would be AQ dot unit vector of B. This would give me the projection of the vector AQ on the line, which means I would get this distance out, the distance AF. Can you figure out why I'm trying to get the distance AF?
When you find AF, then you can find FA and then AQ.
No, when I find AF, तो I already have FA. हाँ, so AF आ गया, AF के साथ मुझे एक और कौन सी चीज चाहिए?
AQ.
Yes, how do I get the distance AQ? By taking the mod of the vector. And once I have AF in AQ, then it's a right angle triangle. It's a right angle triangle. All you need to do is use Pythagoras theorem and you'll get this distance FQ. So this one concept, this only new thing that we're using over here is this concept, the projection of the vector. Once I do this, I get this distance, and from that point on, it's simple algebra. I need to get the mod of AQ and then I just need to use Pythagoras theorem. Okay, so AQ dot unit vector D. So AQ is -2, 5. Unit vector of D would be the vector D divided by its own magnitude. Vector D, by the way, is 1 - 2, 2. And clearly the mod of D is 3. 2 square plus 2 square plus 1 divided whole square root 3. So take the vector D and divide by its own magnitude. So it would turn out to be something like this. D vector divided by its own magnitude. Are you all okay to here? And the dot product with AQ. What's the number? Step 1?
Step 1 to other step 2.
I'm trying to find the projection of AQ on the line. So AQ dot product with the unit vector of D. That's how the projection is found. A dot unit vector of D. That gives you the projection of A on the other vector. That's basically the distance from this point, from the start till this point. It's like the length of the shadow. So I'm trying to find the length AF. And through the projection, I'm going to get the length AF. So whatever answer comes out from here would be the length AF. So I just took the unit vector D, vector D divided by its own magnitude, and let's take the dot product here. 4 units. This length is 4 units. This length right here is 4 units. Length AF. Are we good till here?
Yes.
Step 3, get the length AQ. AQ mod will give you the length AQ. What's AQ mod? AQ is this -2 -2 5. Yes, it's root 33. So the length AQ is root 33. This length is root 33. Now this is a right angle triangle. Can I just use the Pythagorean theorem to get the perpendicular distance? Let's do that, and I'm sure your answer will come out to 270. So I can say over here, I'll just make a bubble here. So I can say that AQ square is AF square plus FQ square. So the perpendicular distance FQ would turn out to be 270. This is your step 4. The Pythagorean theorem. When you practice both, some people find this one easy, some people find that one easy.
पता नहीं 10 चीजें साथ में मिला के आपने पता नहीं क्या बना के दिया कैसे इस्तेमाल करें
First one कर दो.
मेरे ख्याल से आज के लिए तो बहुत
सही है काफी है
Guys, please tell me if there is any step. I know this is going to take time. Again, I say you have to go home and do it again and again to get the hang of this step. It's not just that you heard me, you understood in class, and you'll retain it. You'll not be able to retain it. You have to go home and do it yourself. At least twice, both. Then you'll get the hang of the procedure. But I've broken it up into steps. You shouldn't have a problem.
this won't be necessary
We can use any one of them. But I wanted to do this because it involves the concept of the projection of a vector. This might come. This projection of vector concept can come. We've done this last year as well, but we're doing it again, we're revisiting it. So, it's not that you can just forget about this. I mean, you might not want to do this procedure, but you should know this concept of projection.
Thank you.
Okay guys, this is an easy one. It's just 2D. But I want you to do it through vectors. If you've got smaller numbers, you'll be able to do it easily. Practice. Let's get the perpendicular distance from R to the line BQ. So I'll just give you the situation. The situation is something like this. There is a point P and a point Q, and there is an external point R, and we are interested in finding out this distance, the perpendicular distance from R to the line that contains P and Q. Now these are just 2D coordinates, easy to use. Let's do this. Can you first form the equation of the line PQ? If you want to use the first method, then form the equation of the line, because from the equation you get the parametric form. And from the parametric form, you would get the coordinates of the foot of the perpendicular. Step 1. Form the vector equation first.
do we format it like a three-dimensional vector?
नहीं वो उसी कॉलम वेक्टर फॉर्म में सिर्फ बताया 3 क्वाड्रेंट से 2 क्वाड्रेंट्स होंगे. Like the procedure is the same. Get the direction vector first. So the direction vector would be, let's say the direction vector is PQ.
5, 5.
So that's 5, 5. If I'm taking PQ as a direction vector, it's turning out to be 5, 5. Okay, I just want to say one thing over here. Direction vectors, and I'm only talking about direction vectors for lines. You can use a simpler scalar multiple for a direction vector. You don't have to use 5, 5. I can always use, or I can, as a direction vector, I can always use 1, 1. Because 1, 1 is a scalar multiple of 5, 5. All I need is a vector that runs parallel to the line. There can be millions of vectors running parallel to the line. Every scalar multiple vector would run parallel to the line. So, rather than using big numbers in your calculation, for direction vectors only, reduce it to a simpler scalar multiple. So I'm going to use 1, 1. So my vector equation would be, let's use the point P, minus 1, 1 plus lambda times 1, 1. That's your vector equation. Now form the parametric from here. And then those parametric, the parametric form becomes the coordinates for f. That's step 1. So the coordinates of f are minus 1 plus lambda and 1 plus lambda. What was the next step? You find the vector between the foot of the perpendicular and the external point. So either you can find FR or RF. Which one you want to find, FR or RF? Plus FR would be R minus F, 7 minus this would be 8 minus lambda, and this would be 2 minus lambda. Check. You must be getting FR as 8 minus lambda and 2 minus lambda.
Yeah.
Alright. Now what's the step after this? Once you have the vector, you find the dot product of this vector with the direction vector of the line, which is basically your 1, 1. So FR dot direction vector must be 0. That will give you the specific value lambda, which would place F exactly on the line where you would have a perpendicular to the external point. Is lambda 5?
Yeah.
Once you have the value of lambda, what's next? You get the actual vector FR, plug it in 5, so that's 3, negative 3, and then what do you do? Take the mod of FR, and I think you should get U2 as your answer. Root 18 is 3 U2. Are you good? Okay, last part is pretty easy.
Yeah.
There's a last part here.
सर 5 मिनट
The question says, once you have this distance with you, you got this distance by the way, you got this distance as 3 root 2. This distance. The question says, what if you form a triangle with PQR? What if you had formed a triangle with PQR? What would be the area of this triangle?
सर वो उसकी तो वैल्यू है f r की वो हाइट है
What is F? What is the height of the triangle exactly?
p
And
q वो है हमारी बेस है ठीक है ट्रायंगल का फार्मूला लगाएंगे फिर
okay, let's do that. Get the, what would you do? You would get the mod of PQ
And half it.
and multiply by half and multiply by the height. Let's do that. Let's get the area. The area should come out 15. I'm just clearing this out. So the area half, the base is, take the vector PQ, take the mod of it. Times the height is 3 root 2. And by the way, for the mod of PQ, do not take 1 1. 1 1 was the simplest scalar multiple for the sake of getting the direction vector. Your actual PQ is 5 5. So the mod is root 50. Are you good? Any questions?